All right, good afternoon, everybody. We're starting to wrap up Unit 2 with a slightly different topic now. We're going to deal with this thing called the Pythagorean Theorem. Now, as you can see, there are going to be at least 4 videos on this topic. The first one today is on the concept of the Pythagorean Theorem, and the other 3 videos will follow suit. I'll use the same opener document for each of those 4 videos. So with that in mind, let's go ahead and immediately move on to the concept of what the Pythagorean Theorem is. Now, the Pythagorean Theorem is based on a relationship between the sides of a right triangle. And in a right triangle, you'll remember that there is a right angle, usually indicated with a little box in the corner. That right angle is 90 degrees, so this would be considered a right triangle. And every right triangle has, well, it has 3 sides, you wouldn't be surprised. It has one side that is always the longest side. The longest side is, for the record, always across from the 90-degree angle, and this longest side is called the hypotenuse. Hypotenuse. It's a fancy word for the longest side in a right triangle. And these 2 sides here are, well, they're not the hypotenuse, they're the 2 short sides. So let's go call this one short side A and short side B, and I'm going to pretty quickly abbreviate this to just A and B. And the hypotenuse, I guess if we're going to stay alphabetical, I'm not going to usually use the word hypotenuse because it takes too long to write. I'm going to usually use the letter C. So you're going to see me reference A, B, and C. But the goal here is to teach you the concept only of the Pythagorean Theorem. So I'm going to try to do my best art skills here. And what I'm going to try to do is I'm going to make a square off of the short side. Now what I'm going to do is I'm going to imagine a square, whatever this short side length A is here, I'm going to try to make it about the same this way. It's probably not going to be perfect, but I'm going to ask you to kind of use your imagination here. So if this is, 5 units long, this would be 5 units long, and the area would be 5 times 5 or 25. You get the idea, right? So if this is short side A, then down here, this would be short side A as well. And then I guess if we multiplied A times A, we would get something called A squared, right? That would be the area of this square, right? So whatever the side was here, 2 would be times 2, 5 would be times 5, 7 would be times 7, and that would give us the area of that square. Now let's do the same thing off of short side B, which may be the same as A, or it might not be. We use a different variable, so they're allowed to be different. I'm going to try to measure this a little bit more closely this time. So it comes to about here, and you're going to see me use some pretty rough estimating. But you know what, that could have been worse. So if this is short side B, I'm going to go ahead and say this would be short side B as well. So B times B would be B squared. Or again, if this was 7, this would be times 7. If this were 10, this would be times 10. So you get this square here. And then you won't be shocked to see that I'm going to attempt to draw a square off of the last one. This one seems to be the toughest one for me because the angles are always kind of funky. So I'm going to use the back of an old coaster, actually. So just to get the angles right, so bear with me just for a second. I'm going to come off of here, and I'm going to come off of here. And then I'm going to estimate the rest of it to the best of my ability. The hypotenuse is almost exactly the length of the Sharpie. So I'm going to come out to the end of the Sharpie. I'm going to actually go off the page. That's not going to be super helpful. So I'm doing a pretty rough estimate here. And if you can see that, then this would be, let's see, if this is C and this is hypotenuse. I spelled that wrong. Hypotenuse C, then C times C would be C squared. And that C squared would account for this entire area of this big square. So far, all we've really done, it seems, is make some squares. Now here's where the concept of the Pythagorean Theorem essentially begins and ends. What the Pythagorean Theorem says is this. If you take this first square, the A squared one, and you take the second square, which is B squared. Now I'm going to draw them so they look a little bit different. But these don't have to be like that. The A could be the bigger one and the B could be the smaller one. It doesn't really matter. But if you take those two and you add them together, you're going to get, now my space is limited on this small board here, so I'm going to go ahead and extend it bigger than it needs to be. But if you take those two and you add them together, so whatever this is plus whatever this is whatever this is. So this will be c squared. And really, that's it. That's the Pythagorean theorem. If you have a right triangle with a hypotenuse that's across from the 90-degree angle and two short sides, we normally call them A and B, then if you make a square off of this one and a square off of this one, you add them together, that gives you the square off of this one. And we have this kind of formula that we use, a squared plus b squared equals c squared. That's a very classic kind of formula. I'm going to show you a few quick, that's from a different video. Let's see, we need some more paper here. Those of you that have been watching my videos know that sometimes we make videos on different things. It looks like we're pretty lined up here. So watch a couple applications. If I were to make a small right triangle here, let's just be clear. And I used red in the previous one, so I'll try to use red again here. Let's imagine this. If I told you that this was 25 square units and this was 36 square units, so that's the area of the blue and the area of the blue over here, then to find the red one, we would simply take the 25 plus the 36, 1 carry the 1, and 61 square units, and we could quickly find the area of the large one as well. And you could probably imagine we could work backwards. If I gave you the red one and gave you a blue one, we could subtract to find the missing one, or likewise, red and blue, subtract and get the other blue. So add the two smalls, get the big, and you're done.